What if the best way to understand the quirks of our own minds wasn't to look inward, but to look at the machines we're trying to build? Okay, let's dive into this. Because as it turns out, the quest to create artificial intelligence has accidentally given us the clearest blueprint of our own irrationality. So, the author Rolf Dobelli really hits the nail on the head with this one. It's a classic mental glitch called survivorship bias. We look at the triumphant startups, the rock star musicians, the winning athletes, and we think, hey, I can do that. But what we're not seeing are the thousands of failed businesses and forgotten bands, the huge silent graveyard of projects that just didn't make it. Our brains are just wired to focus on the flashy success stories. And this really brings us to the core question here. How is it that we can compose symphonies and send rovers to Mars, but we constantly fall for these simple, predictable mental traps? What is going on inside our heads? Well, the answer lies in something called cognitive bias. And here's the crucial part. These aren't just random slip-ups. No, they are predictable, systematic patterns in our thinking. It's probably best to think of them as bugs in our mental operating system, kind of left over from an evolutionary past where making a quick decision was way more important than making a perfectly logical one. For decades, the big dream of artificial intelligence has been to build a mind that's completely free from these bugs. A thinking machine that operates on pure, cold logic, without all the messy, emotional, and cognitive baggage that makes us, well, human. And if you look at this timeline, you can see just how deep this idea runs. I mean, right from the very beginning, with McCulloch and Pitts modeling neurons as simple on-off switches, the whole goal was to ground intelligence in formal logic. By the late 1950s, entire labs were dedicated to this vision of creating intelligence just by programming the rules of rational thought. So, the early pioneers of AI were all guided by this one really powerful hypothesis, that thinking is basically a form of computation, that any intelligent action, whether it's from a human or a machine, is just the result of manipulating symbols according to logical rules. Forget gut feelings, forget biases. This was all about pure processing. And this sets up a really fascinating contrast, doesn't it? How do our messy, evolved brains actually stack up against these purely logical agents that we're trying to create? Well, the differences are pretty profound. Well, let's be honest with ourselves. We are absolute suckers for a good story. A compelling narrative with a clear beginning, a middle, and an end can persuade us of almost anything, even when it flies in the face of the actual facts. Dobelli calls this the story bias. So when a really complex situation gets boiled down into a simple, plausible tale, we feel like we get it. We feel like we understand it. But that feeling of understanding, it's often just an illusion. It makes us overconfident and, as he puts it, encourages us to take a stroll on thin ice. An AI, on the other hand, it couldn't care less about a good story. A well-designed system is built to rely on evidence, on statistical reality. It doesn't get swept away by some charismatic narrative. It just wants the numbers, plain and simple. Okay, so how does an AI actually achieve this kind of discipline? Well, one of its key tools is something called Bayes' rule. It's basically a mathematical formula that lets a system start with an initial belief and then rationally update that belief as new data comes in. It's a formal mathematical process for changing your mind based on evidence, which is the exact opposite of us stubbornly clinging to a story just because we like it. And this brings us to a really critical insight. See, AI isn't just different from us. We are actively programming it to be better than us, to sidestep the very same mental errors we just can't seem to shake. Have you ever thought something like this? I mean, come on, you're sticking with a bad movie, a failing project, maybe even a failing relationship just because you've already put so much time or money into it. This is such a classic cognitive trap. Yep, it's called the sunk cost fallacy. We let these past investments, costs that we can't get back, cloud our judgment about the future. But a goal-based AI agent, it's programmed to be absolutely ruthless about this. It doesn't care one bit what's already been spent. It only assesses future costs and benefits to find the best path forward. It literally cannot feel the pain of wasted effort. And this whole design philosophy goes way beyond just sunk costs. Think about the availability bias. That's why we're more afraid of a plane crash than a car crash, right? The dramatic story just sticks in our mind. An AI, though, can be built to rely purely on the cold, hard statistical reality. And then there's confirmation bias, our tendency to hunt for any evidence that proves we're right. A well-designed system can be programmed to do the exact opposite, to actively search for data that disproves its own hypothesis. And finally, we all suffer from the overconfidence effect. An AI can be calibrated to stated certainty as a precise probability, honestly admitting the limits of what it knows. So when you put all of this together, something really amazing starts to emerge. The project of building an artificial mind is actually teaching us more about our natural minds than we ever could have expected. The investor Warren Buffett captures this idea perfectly with this concept of via negativa, the path of subtraction. He says that he and his partner haven't learned how to solve difficult problems, they've learned how to avoid them. And that is exactly what we're doing with AI. We are teaching it how to think clearly by first teaching it what not to do. And this reveals the fundamental insight, right? You can't program a machine to be rational until you've first written down the actual rules of rationality. You can't tell it to avoid cognitive biases until you've first identified, named, and defined exactly what those biases are. So this is the big takeaway here. In our attempt to create a mind with our own flaws, we have been forced to create the most comprehensive catalog of those flaws that has ever been assembled. The quest to build a non-human thinker has become this incredible, unprecedented journey into what it means to be a human thinker. And that leaves us with one final thought to ponder. As these systems get more and more capable, are we just building a better calculator? Or are we, for the very first time in history, holding up a perfectly clear, unflinchingly logical mirror to the beautiful, the brilliant, and the deeply flawed software that's running in our own minds?